Welcome back. Now let us treat the first one here, and that is OLS Regression Analysis. OLS Regression Analysis. Let's treat it first. Yeah. When you click on it, of course, you have to wait for it to initialize, and then before it will bring out the form. Very good. This is data form. This is data form. Now maybe just less than maybe 30 seconds brought out the data form. Now this is the data form. The data form for OLS regression. Now if you look at what we have here, we have the dependent variable name, the independent variable names, and then you have time interval variables, but here, because they are not going to be needed here, therefore they were kind of deactivated. That is, the time interval and the variable groups were deactivated here because they are not going to be needed. So the one that we make use of is the dependent variable name, then independent variable name, and then the name of data set. Now we are going to do two analysis based on two files, which I'm going to show you later. But now let us do this one. Now the dependent variable in this one, we type it as MISR. Now notice one thing. I type in all capital because here, in that particular, I will show you later, in that particular data set, this particular data was saved or was defined in all capital. So that is why I'm typing it in all capital. If I type it in small letter or a mixture, it will be rejected. Now I press, I go to the other one, which is this. Now this is the time for me now to type the independent variable or the predictors. Now we want to see how MISR is influenced by these predictors I'm going to type now. We have RSR. That's the first one. It's also in capital. Then we have GCI, also in capital. Then we have M. M here is not in capital. Then you have M here is not in capital. Then you have CRAT. Now these are 1, 2, 3, 4. Okay, now let's make it up to 5. The fifth one should be OBEP, also in capital. Now, having done that, now there's something I want you to look at very well. You can see when I typed these names, I separated them with comma only, no space in between the comma and the next one. There should not be any space, no space. Just the comma is the separator of all this, comma only. Once you're able to do it that very way, then you've gotten it right. No space in between, no space before, no space after. Just as you are finished, then you can press the tab key to move the cursor to the next one. Now, like I said, this particular two, they were deactivated, but now we now come to the other one. Now, this is showing that there is a kind of a space, or rather a white space in that place. So we have to first of all clean it off, otherwise it will generate error for us. So now we have cleaned off the white space. Now this is now left for us to now type the name of that data set. Remember, this is an Excel file. We don't need to put the extension. All we need is just the name. So the name that this particular data set was used, the name that was used to save this particular data set is DTGI. Now, whether you type DTGI in capital or you type it in a small letter, it will be accepted because this is a file name and not a variable name. It's only variable that must be case sensitive, but file names are not case sensitive. So having done that, the next thing is for us to click process. Now we have clicked process. Now there's something is brought out here. We have to look at it also very well. Now, it said that graph plot selection. You have to make a choice here. Now, there are, it shows line graph, whether you want a line graph. There are other ones that are there. If I click this downward arrow, I will see them. Okay. It said line graph, histogram, scatter diagram, box plot, or first three. That means line graph, histogram, or scatter diagram, or all of the four. So if you choose all the four, it will plot the line graph, it will plot the histogram, it will plot the scatter diagram, and it will also plot the box plot. But if you choose only line graph, it will only plot the line graph for you. So now let's choose the four and see what happens. Yeah, having chosen the four, we now click OK, and then yeah, so I think it has finished with the processing. Now let us look at what the result says. Now this is the results of the processing. Let me bring it out so that you can see it properly. This is the result of the processing. Now, yeah, this is it, VSP. Now, first of all, it will give you the data set used. Now, however, it cropped the data set used because you can always get that one from your Excel, but it gave the first 5 and the last 5 of the data set used. Now, then the total is 73. Yeah, it's giving about 4 user warnings here, but this is not fatal to our case. But now let's see. We'll come here now to see the descriptive statistics. The descriptive statistics for the ones for this thing that we use. Look, the count is 73, the RSR, the GCI, CRAT, and then OBEP. Now, here it also shows the Watson statistics, then Shapiro statistics, and the Shapiro p-value. Then it goes on to now show the t-stats for each of the variables. The t-stat for the constants, the t-stat for the RSR, the t-stat for GCI, the t-stat for M, the t-stat for CRAT, the t-stat for OBEP. Now, the data type that was used, float 64, and that's the jargon of the Python interpreter. Then, now, you now see the p-values for each of these statistics, for these statistics. The p-value for constant is 0.14, which is not significant. In fact, all of them were not significant based on a 5% p-value. Then you now look at the beta factors. The constant has 305.2 as the beta factor. RSR has -2. Then GCI has -56. M has 204.4. And then CRAT, that's CRAT, is 45.7, and OBEP -2, and so on and so forth. Now, this is a variance inflation factor for them. The variance inflation factor, which is a measure of that's collinearity, multicollinearity. Now, you can say that in this particular case, all the, apart from the constants, all the variables used are lower than 5, which is within acceptable range. So now, yeah, after this we have the correlation matrix. The correlation matrix also shows that none of these is except for CRAT, which is and of course M. No, not M. CRAT, and then is high, but not higher than as required, and M to RSR, and so on and so forth. So that's that. Then here it also brings out the Bridge-Pagan tests of heteroscedasticity, and it's the F-test p-value, which is not in any way significant. F statistics, LM tests, LM statics, and so on and so forth. Then it also has white tests, heteroscedasticity also, LM statistics, and so on and so forth. And then the unit root test. So here the unit root test shows a figure, that Philip-Perron unit root test. It shows a figure minus 6.1998, and the p-value is 0.00, which is very, very, very significant. Now, we now look at the last thing that, the last information that is giving us here. It's trying to tell us that the analysis results is contained in value start full regression.txt, and then the plots that we have just made is in the various files, which we are going to open one after the other. He said the histogram plot is in histogram, and then the bus plot is in that line, is in there. Now let us go and look at this. We now, first of all, we have to open the file explorer, and then look for value start. Now this is C. Yeah, this is value start here. Yeah, now this is the value start. No? Wow. That's my person. This is the value start. Yeah. This is the value start. Now, these are, I will look for this. Okay, look at the plots. Now, where is this? Sorry, let's look at this. Okay, this is it now. So, yeah. So now let's look at it. This is the, first of all, the box plot. But before, let's look at the full reg report. That is full regression report that was thrown up. Now this is it. This is the saved one. This is the saved one. You can see the way it is arranged. This is the saved one. You can see it. Yeah. Complete multivariate regression analysis results. Yeah, so look at it now. The dependent variable is MISR. The model is OLS. Method is least squared. Date produced is Wednesday, 10 July 2024. The time is 16:32:59. The number of observations is 73. Degree of freedom of residuals is 67. Degree of freedom of model is 5. Then the covariance type is non-robust. Now, the R squared is 0.057. Adjusted R squared is minus 0.014. The F statistics is 0.8036. While probability of F statistics is 0.551, which is not significant. Then the log likelihood is minus 564.47. Then the AIC is 1141. The BIC is 1155. Now, going further under, we have other, as this is now the detailed results. The constant, the coefficient is 305.2949. RSR is minus 2. GCR is minus 56 points. Then M is 204 points. Then CRAT is 45. OPEP is minus 2. Now the standard error is this, and the T values are these, while the P values for them are this. None of them is significant, just like we saw on the screen. And then you also have the higher value and the lower value for that. Then the omnibus is 101. The Watson, like we've already seen, is this. Jackie Berra is this. Probability of Jackie Berra is 0.0, which is significant. Then conditional number 279. Then kurtosis is 24.263, and then the skewness is 4.466, and then the probability of the omnibus is 0.000, which is also significant. So now it's still going on. Now omnibus, okay, we have talked about that. Now let us go to these other ones. Now we have the standard errors. Assume that the covariance matrix of the error is correctly specified. Then descriptive statistics is this. We didn't give it at first, but we're now giving it here. And then the W Watson is also stated, and so on and so forth. Then the covariance. All what is stated there is also stated there. The unit root test, data set used, and so on and so forth. So that is about the result. So you can print this. This is just in text file. This result is just in text file. You can print this. You can just go to the file, and of course you can see the print. So you can print this out. Now yeah, so now let us yeah, so now we have seen the result, the full red result. Now let us look at the plots that were generated by the analysis. Now let's look at this. Okay, and these are the plots, the box plots, very small compared to the MISR, which is the dependent variable. So now let us look at the line. Now this is the line, P line. You can see that dash is the perfect prediction line, while the dots represents, the actual versus predicted. Okay, and that's for that. Now let us now look at the histogram. Yeah, that's the histogram. The histogram is saying everything about this. Hello?
Hello. Good evening, sir.
Good evening.
It's me.
Huh?
It's
Hello? So, sorry about that interruption. This is the histogram, first bar chart, or whatever. You can see the RSR on GCI, CRAT, then OBEP, and the M. All of them in one sheet there. Now let's take this one off. Now look at the line graph is the one. Okay, look at this is the line graph produced. You can see this blue line represent the RSR, which is the highest of them, and then all others are the way they are. Okay. Now then let's look at the scatter plots too. Now there is a scatter plot. Remember that we selected all four. We selected all four for the plots that it produced. Okay, so that's it. Now that is for the first. Now let us let us do another analysis, another regression analysis using another file. Now I'm going to use a file which is different from the DTGI. We are waiting for the form to come up. Good. The form has come up just like before. We take the cursor to the first one. In this particular one, we are trying to see how the meal prepared is related to the ingredients that was used to prepare it. So the dependent variable here is meal. Then we now go on to the other ones. The independent variable here, let's say egg, oil, SES maybe for seasoning, and then SAL for salt. Okay, man, let's just limit it to this only 4. See, as before, only the independent variable was separated by only comma as before, no space in between them. So we now move on to the other one. You know, the time variables have been deactivated. The variable groups were also deactivated. Now we'll now go to the name of dataset. Here, the name of the dataset was saved as sumtas.xls, but you don't need to put xls there. So now, having done that, we click process. And of course, it will also have to tell us to choose the type of graph that we want it to produce for us. So here, maybe let's just choose the first 3. And then we click okay. Yeah, as usual, it has produced what we are looking for. Now, as before, yeah, so this one, anyway, didn't clean up the first one. This one started here. The data set that was used is this. You can see the variables. Look at the dependent variable here, which is meal. Look at all other ones that are there. There are some that I didn't use because they are not necessary here. We are going to use them in the other ones. So we'll now go on, and then this is it, VSP. Then it started with descriptive statistics. Watson says this is 2.0, unlike the other one. Then Shapiro, p-value 0.100, and then the t-statistics, and then almost none. None is also, none of it is significant. Variance inflation factor, this is just too beautiful. None of them show sign of collinearity apart from then the constant. Then the correlation matrix is also there to show that none of them is higher, apart from maybe egg to cell and so on and so forth, which is crossing about 0.46. Then we also look at breech pagan. This time around, the breech pagan is the breech pagan. This thing is significant, and then white was not significant, and then unit root test of Philip-Perron was also significant here. And of course, like before, it is also directing us to go to for the detailed results in value star full egg and so on and so forth. Now let's try to do that. Let's try to do that. Yeah, so let's look at this. Yeah, so yeah, you can see with this one now, you can see that this thing changed, the dependent variable changed, meal. Now let us look at the R squared. R squared, this one is 0.016. Adjusted R squared is all this, and so on and so forth. So now the same thing, it gives you exactly all that you require, and then let us look at the line graph. Okay, scatter plot for this. Yeah, look at the scatter plot for this one. See the different colors represent the different variables. Now let's look at another one. The line, very good. This is the line graph. The line graph for the data use. You can see there are some that are so low because of their value, and some very high up, and all of them are there. So this is a very nice one. Yeah, the histogram. Now for egg, for oil, for cess, and then for I think, was it data? Yeah, so that's how that one looked like. Then the P line, let's see, the P line is a plotted line against, okay, you can see the scatter is still very far from the prediction line, which is, anyway, this is just a figure that is just generated, may not represent, wow, may not represent actual this. Now let's look at the box plot now. See how this one differs from the first one. Okay, it's almost like the first one, but no problem. Okay, it was actually the first one. All right, so okay, we didn't include the box plot this time around. That is because we used the first three, which excluded the box plot. So now that is that. Now let us even look at let's look at the data. Let's look at the data that we use, that is the data set that we use. Let's see, so that I will now show you what informed the use of capital letter for the first one and the use of the small letter for the second one. Now let's look at it. The other one was DTGI. That is yeah, good. This is the data file in Excel. Now let us now see how it was defined that made us to now good. Now, if you look at this place, you see that the first row, that is where, look at the company ID is for A. Then the first row is the one that specified the name for the data. And look at the way it is. MISR is in capital, GCI is in capital, CRAT, okay, or CRAT, CRAT. C is in capital, R and A and T are in small letters. We didn't use a Z score, but we also use a RSRL. We didn't use DTGI here, but we use OBEP. And you can see that those that appeared here in capital also appeared in the form in capital. Otherwise, it will give error. Those that appeared in small letter also appeared in small letter. The one that has a mixture, like that of CRAT, also have a mixture. Otherwise, it will give error. So that is that. Now, let us look at the second one that we also used, SUMTAS. Yeah, good. That is SUMTAS there. Now, let's open it. Yeah, so now you can see from what we have shown that everything here was in small letter, and that is why I have to type everything in small letter. Look at the meal, the SES, oil, Ing 1, Ing 2, even though we didn't use this variable, we didn't use Ing 1, Ing 2, Ing 3. We use only meal for the dependent variable. We use egg, we use sal, we use oil, and we use SES. So that's how it is. So now you have to remember this. The way you type the name of your data is the way you are going to type it in the form. Then you save it the way it's supposed to be saved. And it must be saved in the C value start folder if it is on Windows, or in the root value start folder if it is in Linux or in Mac OS. So thank you, and I believe this must have been very helpful to you. Thank you. This is for OLS